still alive. Oh my God. I hope that you are doing all very well. We have going to start setting up the equipment first. We talked about setting up reflux last class. So basically, I'm going to bring the hardwares out first, and then the glasswares. Glasswares is going to come out last. We do need a utility clamp to hold the boiling flask. I'm using a ring stand this time because we don't need the hot plate. I'm using a ring stand to support heating mantle. It cannot stay on the bench top. It has to be elevated. So I'm using iron ring to support the heating mantle. Heating mantle cannot be plugged into directly to the wall. So we are using a power regulator for the power. And I'm going to plug in when everything else is ready. Using a 3-finger clamp to support the condenser. And the good thing about the 3-finger clamp is that we can adjust the arm length and make sure that this stays straight up and same level with the utility clamp. Okay, the hardwares are ready. Now I'm going to use, if I can find the blue glass right here. We are going to set up first with the empty flask, just to complete the setup. Then I will add the chemicals later. So basically I've lowered the heating mantle later to get the chemicals into the flask and put it back. For a glass joint, we want to make sure that all the glass joints are greased. So I'm using a vacuum grease to grease the joints. I don't want to get the grease into the flask while I'm putting the chemicals in, so I'm keeping it separate. When I have the chemicals in, then I will attach it. So I just want to adjust the length, make sure that is on. Water hoses, it would be the lower end, water in. So I attach the lower end to the faucet for water in, and the upper end, it would be used for the water flow, so it would go disposal down the drain. As we finish up the assembly and bring my chemicals, I turn on the water first, then I turn on the heat, but I have to first get the chemicals in. Based on the procedure, the 10 grams of the benzoic acid with 25 milliliters of the methanol, 10 grams of benzoic acid, you could use funnel to transfer, or make a funnel with your plain paper and transfer the chemical into the flask. So that was 10 grams of benzoic acid based on the procedure. So we're not changing for anything. And 25 milliliters of methanol in a 100 ml flask. And I need to add the 3 milliliters of concentrated sulfuric acid. Concentrated sulfuric acid needs to be added inside the fume hood and slowly. So when you add sulfuric acid, it generates heat. And if you add all of it at the same time, it can boil the solution. It can foam out of the solution. Because you have concentrated acid, the fumes are highly corrosive. And if it touches your skin, it's going to be highly corrosive. At the same time, you're going to lose your reactant. So whenever you have any exothermic interaction, you want to make sure to slow down the reaction to control any spillage or any problem. Sometimes your reaction it's like highly exothermic. It produces huge or significant amount of the heat. In that case, you can place your flask inside a iced water bath, inside ice, and you can add the acid slowly. That way, the temperature doesn't go too high, especially. And reflux. Is boiling chips mentioned there, or we understand that from last experiment we have to do reflux? Yes, boiling chips is there. Okay. Even if it's not there, we have to add the boiling chips. They're mentioned? Okay, good. So we add boiling chips. I already greased the glass trays. I'm going to use the cap clamp to hold the two glass pieces together. The heating mantle is what is used as the heating source for reflux, because the shape of the heating mantle, when you have like this round shape, and the flask is going to be heated up like more evenly. It's not like a hot plate that only bottom of the flask is being heated up. So you have that nice shape of like perfect fit. And if in the screenshot files or picture files for experiment 13, I turned on the heat now. I am going to set it up around 60, between 50 and 60, because it's methanol. It should boil quickly. And I didn't check if the heating mantle is working or not. It's better practice before you connect it and wait. You can just check this to make sure that it's working, it's heating up. So it is heating up. Just gonna let it heat up and start boiling. The reflux has started now. Experiment. Today's experiment is esterification. Benzoic acid. You add the alcohol, which was the methanol. Sulfuric acid, which we are using in this reaction, it's just a catalyst. And the product, we actually get two products here, is going to be methyl benzoate and water. This reaction is a reversible reaction. So if you increase the concentration of the water, the reaction would go to left. If you increase concentration of methanol, the reaction would go forward. So basically, we used excess amount of methanol. We used the 25 milliliters, that was excess amount of the methanol if you calculate the mole ratio, you can actually find the number of moles for methanol and benzoic acid. So we are using high volume or excess amount of methanol to make sure the reaction is going to forward and formation of methyl benzoate. Whenever you see a double arrow, you should remember the Le Chatelet's principle. If you want the reaction to go to forward, you have to use excess amount of the reactant or remove one of the product. If we had a way to remove the water in this reaction, we would make sure we will get more methyl benzoate or the product of this reaction. One of the methods to remove the water is like you have to basically apply heat to 100 degrees Celsius, which is impossible in this reaction. Why is it impossible to apply heat of 100 degrees Celsius in this reaction during the reflux? Because it's a closed system. Actually, I'm glad that you said it's a closed system. This mixture is not boiling in a closed system. It's dangerous to have your either distillation or reflux in a closed system. It is open. The top of the condenser. When I take the laptop there, I will show you again. The top of condenser is open, and any vapor or excess of vapor can actually exit through the top of the condenser. And that's a good thing, because then if we see the vapor coming out, that means we are using too much heat, or maybe by mistake the water was turned off and the condenser is not cooling, or instead of connecting to cold water, you connect to hot water and your condenser is like heating pad now, or you are applying too much heat, which then you have to lower the temperature or lower the setting on the power regulator, make sure the temperature stays controlled for gentle boiling. So gentle boiling is a boiling that it produces vapor, it keeps the temperature high at the boiling point of the solvent, but at the same time, you don't lose the vapor. It allows the vapor to condense from the condenser back into the boiling flask. Points for this reaction: the experiment based on the lab technique. Again, setting up the reflux. Why we are using reflux? Because the reaction takes time, requires high heat. So we are going to, we have to use reflux to make sure the reaction is happening for a long time at the high temperature. And to assemble the reflux, again, greasing the glass joint is very important. You should never put any stopper at the end of the condenser, because this condenser knob is open. You don't want to block it. If you block it, the vapor that is produced inside the boiling flask, it can build up high pressure. It can break the glass. It can cause other accidents and incidents. So boiling should never take place in closed container. That could be distillation, or it could be reflux. So this is open system actually. If you apply too much heat, you will see vapor coming out of this. You are losing the sample, because your condenser is not efficient. Either you have too much vapor or the water flow is not efficient. Can you tell me how do we prove this reaction has taken place? And talking about that is going to again remind me of design of the experiment. When you have experiment that is designed for you, especially like for teaching lab, it must give you a proper procedure that is going to help you to follow the experiment step by step. So you already expect what should happen. So you have to have a chemical reaction. In your chemical reaction, when you are following the procedure, like in this case, when it tells you 10 grams of benzoic acid, 25 milliliters of methanol, you already know that you have a chemical reaction, and this chemical reaction is going to happen with limiting reactant and excess compound. So you need to know which one is limiting, which one is the excess compound. When you are done with this reaction, a complete reaction, it should have, or a complete procedure or good design of the experiment should have a procedure part that is going to allow you to purify your product. Because when you get your product, you're going to get crude product. And what is crude product? Is the product that you think, or you assume, or you're sure that your reaction has taken place, but it's not purified. It's mixed with the excess amount, it's mixed with the catalyst, it's mixed with everything that you have in your reaction mixture. You're not going to get 25 milliliters of ester. 25 milliliters of ester is a lot of ester. And I should say, you might know. I was going to say we know. Esters are fruity flavor additives that is actually added to food products, as well as like some air fresheners, sprays, or other cosmetics. So esters are not hard to make them. So it just takes like few drops of the acid, alcohol, and the carboxylic acid. It depends on the size of the alcohol that you are using, size of the acid that you are using. You can make ester that has strawberry flavor, or it has mint flavor, or it has like oil of wintergreen or banana, cherry, different type of flavors. So all different flavors of ester can be made with the simple reaction of esterification, or Fischer esterification rather, because you are using carboxylic acid and ethanol and alcohol in general. And depends on the size of the acid, size of the alcohol, you get different flavors. If you search up for how to make ester, you will get a table with the list of what should be the choice of acid, what should be the choice of the alcohol, if you want to get banana flavor, or you want to get strawberry or cherry or pineapple, pear, any fruit flavor that you get. Is the ester is a product of esterification. And when you read the food label, let's say you have like pack of candy, you buy it like 1 pound of candy for $1, and it's like it tastes like a strawberry, or it's strawberry flavored. Believe me, they didn't pick the fresh strawberries for you to make that candy, because if they did pick fresh strawberry, you wouldn't buy the candy for $1, the pack of candy for $1. So the strawberry flavored, or you have like cherry Coke. When you have a cherry Coke that's actually Coke, okay, which is the sugar and some colors and the water and carbon dioxide, plus some caffeine if it's not decaffeinated, and then plus some esters that they actually make in the lab. 1 milliliter of the ester is enough to flavor about 100 pounds of candy. So when they say artificially flavored, that's basically adding of esters to those food products. So application of this experiment, it's very significant in the food industry at home, but when the product that you are getting, it must be purified. So you have a chemical reaction that you're basing your procedure based on. You're starting your procedures. You have a chemical reaction. So when you write the procedure, your procedure should include a limiting reactant and excess compound, because if you don't have excess compound, your reaction actually is going to have, especially if it reaches equilibrium, the yield of the reaction is going to be very low, and you don't want low yield of the reaction. Then you have to have a purification technique. What is the purification technique in this experiment? You could get extraction, you could get distillation, you could get, if you have a solid compound, you could get recrystallization. And in this case, you are using extraction, right? Because you are using butyl methyl ether to extract the product. So after your reaction is done, you would do extraction for purification of the crude product. And what is the last step? The last step to make sure your reaction is complete, your experiment is complete, you have to have a way of identification. How would you make sure your reaction actually took place? How could we prove that our product is ester and is not the benzoic acid mixed with methanol, is not water? What did you see in this experiment?
An IR at the end.
IR. And I'm not sure how much of the IR you have been exposed to or you know already. IR is the infrared spectroscopy. With the infrared spectroscopy, you can identify functional group, and each functional group has a specific wave number that the peak appears in that location. So for alcohol, the peak is going to be around 3300. For ketone is going to be, that's for OH1. For ketone is going to be CO double bond around 1700. For aldehyde, you are going to have a peak around 1700 plus two other peaks, one at 2700, one at 2800. A carbon-carbon triple bond would show a sharp peak at 3300. So based on the IR, you can determine the functional group. When we are learning IR, that would be like experiment 17, that we will have some introductory IR. We learn those numbers, but when we are using application of the IR in the experiment, we look at our experiment to say, okay, what is the point of difference here? I have carboxylic acid, I have ester. Carboxylic acid, if it's open chain carboxylic acid, if it's not conjugated, is going to have a peak at 1715. Okay, 1715. Ester, if it's not conjugated, is going to have a peak at 1730 to 1740. So basically, the location of the CO double bond peak is going to shift from 1715 to 1730 or 1735, 1740, depends on what are the environments of that CO double bond. Then it's going to change. If you use IR, you can also prove that your compound is pure. You could use the pH. The pH is expected to drop if your sample is pure. But if there's any impurity left over of the sulfuric acid, still is going to show you low pH. But pH by itself is a qualitative analysis. It's not strong enough to determine the purity of the sample. So we can predict that the pH in this case is going to increase because carboxylic acid is being consumed and ester is being produced. But to defend your case that you do have pure product or definitely have a product, you need a stronger, like melting point last time. Melting point is very reliable. IR is reliable if your compound is pure. If the compound is not pure, again, the old saying of chemists, garbage in, garbage out. IR, it takes like 3 minutes to do experiment with the IR or less. It's very non-invasive. You take a drop of the sample for it, and the only problem with that is that if your sample is not pure, if it has any impurities of alcohol, it's going to show peak at 300. Then you don't know if this is coming from carboxylic acid OH or is the impurity from the alcohol, or if there is leftover of benzoic acid. Benzoic acid is going to be, because you are washing with water, you're washing with the acid and the sodium bicarbonate, it should be removed. It should be removed during the experiment. But if there is any leftover, it's going to have also peak at broad peak between 2500 and 3500. So you have the method that is used for identification today is going to be IR. During the procedure, during the extraction, what is extraction? Did you review extraction from previous experiments, from either experiment 4 or from the lab techniques? for extraction. How extraction is applied in this experiment? Why are we using extraction? Or when we do extraction, what is actually happening? We are using ether as the extraction, and our product is a methyl benzoate. Using extraction, basically you have to set up extraction, and you are using separator funnel for the extraction. In extraction, you have two layers. One is a organic layer, and the other one is aqueous layer. The organic layer or aqueous layer is determined based on density of the two layers that you have. So you are going to have two immiscible layers. So you have to choose your solvent properly. The extracting solvent, it should dissolve your compound of interest. So in this case, the methyl benzoate should be dissolved in the solvent that you are choosing, which is the ether. Because it's polar, we pick like an ether as a polar solvent that is going to dissolve the methyl benzoate. Your extracting solvent cannot be miscible with water. So alcohol or ethanol can dissolve methyl benzoate, but since alcohol is miscible in water, you're going to have everything mixed up in one layer, so you cannot separate it. So it must be immiscible, and it might have high solubility of your sample in that layer, in the extracting layer. So the factor that is used is known as a partition coefficient, and the symbol for that is the KF. Partition coefficient is the difference in solubility of your sample, or ratio of the solubility of sample in the organic layer versus the aqueous layer, and your sample is going to be highly soluble in one layer and very low solubility in another layer. And you have to do multiple extraction. The design of the coffee maker is based on basically extraction, because you think that you're brewing coffee, but you're actually doing extraction. So extraction is used in this case. We are using the ether as organic layer, is going to pull up or dissolve the methyl benzoate in the organic layer. We drain the aqueous layer. Aqueous layer is going to have the methanol, it's going to have the sulfuric acid, and those are the two solubles, yes. If there is a benzoic acid left over in the reaction, where would it stay? In the organic layer or the aqueous layer?
The aqueous layer.
Benzoic acid. Benzoic acid, how many carbons do you have for benzoic acid? 7 carbon for benzoic acid, right? If you have 7 carbon for benzoic acid, anything more than 5 carbon is not going to dissolve in water. So benzoic acid is going to dissolve in hot water, but not cold water. Benzoic acid could stay in the organic layer also. How would you separate the benzoic acid in this reaction? How would you remove the excess of benzoic acid if any left over? That is the answer to your
That's what
question.
we use the.
When you use the sodium bicarbonate, you wash the organic layer with sodium bicarbonate. Is going to react with benzoic acid, and the benzoic acid is going to change that to sodium benzoate. So it's an acid-base reaction. Sodium bicarbonate with benzoic acid is going to give you acid-base reaction. The product is going to be salt and water. So basically you get carbonic acid, H2CO3, decompose because it's very unstable, and when it does decompose, is going to change to water and CO2. And that's why when you are using that solvent to wash your organic layer, you need to make sure to shake it and dry the way you have to vent it. In the fume hood, you have to vent the separator funnel to release the pressure that is built up. Otherwise, you have this holding, or you place on the stand, is going to pop up the cap. It can fly actually distance. It has happened in the lab when students forget to vent it or leave it there for a long time, or the temperature is high, it builds up pressure and is not funny. So if it can hit your eyes, it can cause any, it's just accident. So you have to vent it a couple times. So you are doing multiple washing in this case. You are going to wash with water, you are going to wash with sodium bicarbonate, you are going to wash with sodium chloride. And when you do that, each time, the rule is, I think I told you, like 5-5-5 for the recrystallization. When you have a solid product, you get your sample 5 minutes in ice, 5 minutes in vacuum, run the vacuum, and then 5 minutes for the oven. In the extraction, there are like 3 terms that I use to make it simple for students to remember, and it must be done every time. So you have to, for consecutive extraction, you have to shake it. And when you are shaking, it depends that if you have a chemical reaction or you're trying to wash, you want to emulsify it. So you don't have to shake it really hard, but you have to do that at least 2-3 times. You shake it, vent it, and separate. So shake it, vent it, separate. Shake, vent, separate. Those are the 3 words that it should come right after one another, one after the other. And it kind of rhymes, and you have to remember it that way, because if you add first time is adding sodium bicarbonate. You shake it, you vent it, and you don't separate. Shake and what? Shake, vent. Venting means you open the stopcock to release the pressure. Then you close the stopcock, bring it to the right position. You place inside the iron ring and let the layers to separate with the 2 layers form, and take the cap off. Open the stopcock to drain the lower layer. If you don't drain it and you go next step, wash with sodium chloride, then you are going, or wash with water, that is going to just react with the sodium bicarbonate. It's not going to wash the organic layer. Or sometimes you are doing consecutive extraction. If you add the first portion of the solvent and the first like 15 milliliters of the ether, and then you would not separate it, then you add the second 10 milliliter or 15 milliliter, you add it, you separate once, that's just one extract, counts as one extraction. It doesn't count as 2-3 extraction. The greater number of extraction, the better the separation, because the extraction is based on partition coefficient, or the difference in solubility in the organic layer versus, or extracting layer versus the other layer. So for this, you are going to have the let's say your compound is 90% soluble in organic layer, 10% soluble in water or aqueous layer. So your solvent sounds good. You can separate 90% each time you do extraction. So with the first extraction, you get 90% of the organic layer out. You separate, you leave it in a container. Then the second time when you do extraction, you get 90% of the 10% that is left. That is like 9%. And if you repeat for the third time, you get 90% of the 1% that is left. So it's going to make it better separation. But if you do just one-time extraction, you only get 90%. So you get 10% loss, one-time extraction. It doesn't matter what is the volume of the solvent, you still get 90% if the solubility is like 90%, 10%. When you look at the coffee makers, like the traditional for American coffee, making or brewing American coffee, it doesn't pour the hot water, like 1 cup of hot water through the coffee beans or the coffee grind. What it does, it changes the water first to steam, and then it's going to spray the steam. One time, like in multiple times. If you open the coffee, like the top, the coffee maker, you would actually see that is actually spraying the water or the steam or hot water. Now, you can buy coffee maker maybe for $10. I have purchased one, and you could buy it for like 1,000 or 1,600 also. I've seen one, but the design of it is like, why one is so expensive is because they can get more extraction, multiple extraction. So instead of like maybe 50 extraction, it can get up to like 200 extraction, or they can produce like higher temperature of the water. So if the higher the temperature is going to dissolve that caffeine and the flavor of the coffee more, and then you get more rich and more like a flavored coffee. That's another. Sometimes they just produce steam. So if you have an espresso maker, it's not passing the water through through the coffee grind. It's passing steam through the coffee grind, and it extracts more because steam you can increase the temperature of steam to as many temperature you want, as high as you want it, but water cannot pass the boiling point of water. So if it's liquid, it's going to be water temperature of boiling point of water. But if you change it to steam, then you can put very high, especially at high pressure, you can put very high temperature on the steam. So then the design of the coffee maker makes the difference in the price of the coffee maker. So that's how you use your multiple extraction. The cap for the separator funnel also must be greased, because if it's not greased, when you turn it around and try to do shaking part, everything from if it's not completely sealed, then you would get that liquid leaking out into your hand. You don't want to do that. And I'm not going to put the cap on because I have grease and I don't want my chemicals get grease on. So I can use a different one to show you what do I mean? If this part is not sealed, when you are shaking, see how loose it is? It can come out, and it's come out empty is okay, but if you have the chemicals, as soon as it comes out, then you get all the chemicals in your hand. Also, when you vent it, you open the stopcock to vent the vapor or the gas. If you forget to close it before you put it in the top upright position, the chemicals is going to spill everywhere. So you have to be careful with this part also. You vent it, you put it back. It's just like burette that you were using. You want to close the stopcock before you put any chemicals in. And this has to be greased, otherwise it won't be sealed. But has it been 45? Okay, I guess you are correct. And I'm going to show you the setup for extraction. And screenshots are going to be 50 milliliters of water into the separator funnel. So I'm going to add the water. Okay, there is a problem here. The size of this is a 125, so I was expecting the 250, and if I can't find the 250, this is a 125 also. So I'm going to have half the volume here. So I have the water in the separator funnel, and I will detach this and transfer to the separator funnel. Okay. Leave it here for now for being cleaned later. I already unplugged the electronics, and I'm going to also turn off the water. We are going to bring 35 milliliters of the T-butyl ether, T-butyl methyl ether. Shake it, vent it, and bring it back to separate it. So I add the ether. So one of the ways that you can, avoid contamination is like holding the cap using your hand that you're holding the bottle or transferring. It's okay. It's good practice. To cap it, make sure that it's secure, and mix it. Open to release the pressure. Don't know if you hear or not. See the fizzing sound? It's very, it's not, there is no bicarbonate yet, so it's not that strong. Okay, so for 3 times, I shook it and I went it. Now I'm taking back to station. I leave it on the ring stand, take the stopper out for the 2 layers to form. I have the 2 layers here. Is the 2 layer visible? Yes? Okay. Could you take one more screenshot of this? Now that we have the 2 layers separated, I can open the stopcock and drain the bottom layer. You can take a screenshot at any time as we. Okay. I'm not taking the last drop because I don't want to lose any of the top layer. And we go to the next extraction. Push the solution with water. $25 milliliters of the water to wash the solution. Washing is basically removing anything that, any impurity that is water soluble, and we drain the aqueous layer. See what happens if I don't take the cap off and I try to drain it? See, even though stopcock is open, nothing comes out because because it creates vacuum there. So in order for it to get and it's kind of choking and it's trying to get the air from the bottom, and it's going to destroy the equilibrium or the 2 layers. So that's why for better practice or for the right technique, you take the stopcock, the cap or the stopper out first before you open the stopper. You take the glass stopper out first. What's the next solution that I'm supposed to add? The saturated sodium bicarbonate. Remove the cap. What's the purpose of adding sodium bicarbonate again? Excess of the benzoic acid. Because it's an acid-base reaction that it will produce carbonic acid, which decomposes. It can create more of the carbon dioxide. It depends on how much leftover of benzoic acid we have. If you don't have much benzoic acid, it's not going to be, the reaction is not going to be very significant, and you don't see a lot of gas being produced. I guess that those extra minutes that we had with the reflux, it did help for complete reaction, or it did help more with the complete reaction. Okay. We're going to drain. Next, sodium chloride solution. Perfect. With the ether layer, there might be still some moisture, water that is left. Saturated sodium chloride, it acts as a liquid anhydrous agent. It can minimize the water in the organic layer, and it makes, you see that if you notice now, the organic layer, the top layer is more clear. That means there is no water left. Next step, transfer to Erlenmeyer flask, the ether layer. We transfer from the top layer because we know that the bottom layer here we have more moisture. We try to avoid transferring the aqueous layer into. Then we add calcium chloride. How much of calcium chloride should I add? There should be no quantity there. If it gives you, it just tries to make you students not think. But if you have, and I usually have to do it for organic 1, and I normally don't do that for organic 2. The more moisture and water you have in the organic layer, more of calcium chloride is needed. It's very important to close the calcium chloride container right after use, otherwise it would absorb the moisture from the air and it gets like a piece of rock and is not efficient anymore. It would be hard to use it. So when you look at this, now the little crystals or balls of the calcium chloride, if they are moving around, that means they have not absorbed water and they are not saturated. If they absorb water, they become like a paste and they stick to the bottom of the flask. They don't move around. That means they are already saturated with water. In that case, you would need extra calcium chloride to add. I have few that they are moving around, but the bottom of the flask still is like, you have pasty, and you can actually, just to be safe, I'm just going to add about tip of a spatula or half a spatula more to make sure all the water has been removed. Because if the water is not removed here, it won't be removed with the hot plate either, and then it will show up as an OH in IR. That was the anhydrous calcium chloride that would absorb the, and we have the mass of them. Can record that number, please? Can take a screenshot or record the number. See, it's moving a lot. The number is changing because I'm talking and the balance is scale is very sensitive. Whatever number that you catch, that's fine, because the difference in the decimal, so it goes 69.26 to 69.27. It's just because it's very sensitive. When the AC is on, I'm going to show you, like if I fan my hand around this number is going to change even more, like this. It's not the mass that is changing, it's the pressure over the balance that is changing. So you have that number. Now we are going to transfer the liquid portion into the beaker. I'm going to set up the hot plate first and then transfer, just to make sure that there is more of, or most of the moisture is absorbed. You should give about 2 to 5 minutes time for the anhydrous agent to work. transfer the liquid portion only. Basically, you're decanting, meaning that you transfer the liquid without getting any of the solid. We place a wood stick. What wood stick does, it helps the boiling. It's going to make the boiling faster. Is wash that with 3 to 5 milliliters. This is just trying to transfer every drop of the product into the beaker, so it does help percent recovery. To heat it up until it stops boiling. Ether is going to boil at much lower temperature compared to ester. So when the ether is done boiling, then it will be, it's going to be a lot easier or harder. It would require much higher temperature for the ester to boil. So ether would boil first. You won't see any bubbles forming when all the ether is gone. It takes a long time before the ester starts boiling. And for us to be smart, we have to just take the beaker off the hot plate at that point, because we do not want to decompose or evaporate the ester. We want to keep the ester. We want to evaporate the ether. This is going to the solid waste. So I'm going to dispose into the solid waste. The general rule for using gloves in the lab is that when your gloves changes color, it's time to change your gloves. So when you see yellow color on your gloves, that means that you have touched acid or base or something that it should not be there on your hand, on your skin. And the chance that, well, these days we're not supposed to touch our faces anyway, the chance of that being transferred to your face is high. So I didn't dispose this because I wanted to show you, even like this color change of yellow color, that's time for changing your gloves. It's not like doctor's office that as soon as you leave one patient, you have to change gloves. Here, you can keep your gloves on until it changes color. Okay, we use anhydrous agent to dry the solvent. Drying solvent is just removing water from the solvent. And now we are heating up to evaporate the solvent because we have a solution. Our solution is made of ether as solvent and our ester as the solute. We don't need the solvent, we only need the solute. So we have to heat it up in order to get the pure sample. Low heat, like so between like 3 and 4. If you have the boiling point for your ether, you can also use a thermometer. If the solution shows boiling point, let's say boiling point for the ether is 50. Okay. Now, if the solution is boiling, the temperature is not going to pass like much higher than 50. But if the temperature of the mixture reaches like 60 degrees, at that temperature, you're 100% sure that there is no more of the ether left. So you can stop the boiling. But for me, not bringing thermometer or not using thermometer, and also for safety, because then the thermometer could be heavy. I don't want to leave it there. I don't want to take some of it with the thermometer to keep the percent recovery high. Also, I monitor until it stops boiling, and when it does stop boiling, I know the ether is gone. The color is another indication. When you see like a light tan color, you stop heating also. So if it turns like yellow color, dark yellow, brown color, that means you burned your product. So it stopped boiling. I can stop the heat at this point and Since in the procedure and you're not here, I'm going to also bring a thermometer and check the temperature. If the temperature goes higher than 50, I can stop. Okay, temperature is way past 60. Definitely there is no heater there. And I stop the heat at this point. I'm going to leave it to cool down slightly because we don't want to measure the temperature, measure the mass for hot objects. We let it cool down and we measure the mass. With the mass of the product, you can calculate the percent recovery. You have the mass of the beaker already. And this is going to give you the mass of the beaker plus the measuring the mass of the product plus the sample plus the beaker is 78.240. The first thing, I'm going to save the sample and I am going to do the IR first thing